Okay, so I'm going to talk about SQL Server, the isolation levels, and later on deadlocks. So I'm going to go through this document here. So we've got one on the left, one on the right. We've got two sessions, as you'll find out what we use them for shortly. So yep, these scripts show you how to create a deadlock and go into all the different types of isolation levels. So SQL out of the box, as in not in Azure environment, it uses what's called a pure locking model by default. SQL on Azure uses the row versioning by default. So SQL calls this the read committed snapshot. So if on Azure, then you can turn this off to be like the boxed version. So if you were using Azure, you could run this command, alter the database. Our database is called Playground. Set read committed, and we're turning the snapshot off. So this is just to get the database into a consistent state where we have the default just read committed isolation level. We can make sure this is on by running this query. The field we're concerned with is read committed snapshot on, which is all the way to the right here. So it's not on, so we've successfully turned it off. So if you were on Azure, run that, and that would put it in the read committed isolation level. So we can also run this to see all the sessions and their so if you wanted to look at all the sessions and their isolation level, you can run this, so we can see that the one we've got is read committed. So now we've sort of set things up. Snapshot off, yeah, read committed, yeah, all good. So let's just talk about it a bit. So locks are used to guard data resources to prevent conflicting or incompatible access by other transactions. So when you try and modify data, your transaction requests are exclusive lock. Request an exclusive lock on the data resource. If granted, the exclusive lock is held until the end of the transaction. So other transactions can't modify the data resource until it is released. Reading the data resource is a different matter and depends on the isolation level. So it is possible to read even if the row is locked for a write. So the default isolation level for SQL boxed version is read committed. So yeah, off-the-shelf box version of SQL Server, not Azure. The isolation level is read committed. So when you try and read data, this requests a shared lock. It is released straight after the read. Multiple transactions can hold shared locks on the same data resource, and this is known as pessimistic locking. The default isolation level for SQL Azure is read committed snapshot. Instead of only locking, it relies on a combination of locking and row versioning. So reads don't require shared locks and therefore never wait. They rely on row versioning. So this means that even if a row is being written to, it will get the last committed state of the row when the statement started. Everything costs, so this does mean that extra work is needed to be done to create the snapshot, and this is known as optimistic locking. Okay, so locks can lock different types of resources such as rows, pages, tables, and even databases. The ideal lock would be on just the affected rows, but SQL decides based on the concurrency and system resources. So when it estimates that a transaction will interact with a small number of rows, it tends to use row locks. With a larger set, it tends to use page locks. And SQL Server will first acquire the fine-grained locks, such as row and page. In certain circumstances, it may request a table lock to preserve memory. Table locks normally happen when you do a lot of operations, maybe if you change 10% of the data, but you will have to play with the number and see. So yeah, table locks are sort of bad in the long run because they lock the whole table so other things can't access them. So ideally row and page locks, but there will be times when you maybe need a table lock. When transactions hold a lock and another requests an incompatible lock, the other initiated request is blocked and it enters what's known as a wait state. Blocking is normally as long as the requests blocking is normal as long as requests are satisfied with a reasonable time. Long-running transactions result in locks being held for longer periods or even transactions left open. So let's actually write some SQL now. So let's create a table to play with. We're going to create a product table. We're going to insert some data. So let's have a look at what we've got. We've got a product ID, 123, a name for the product, a category, and a price. So it looks like a hardware, timber, 9-inch nails, categories, timber, nails, prices. So this is what we're working with. So let's go through a few examples. So jump straight in and do an example. What we're going to do is we're going to create a transaction here, and I'll get rid of that because that's not needed yet. So we create the transaction. We've now got an open transaction. If I update the row, so this row initially, row number 1 has a price of $8.99. I'm going to update it to £1 more, so it'll be $9.99. If I execute that, we've changed it, so now we need to use this other window over here. So this is our second session. So if we scroll to the top, and it says run session 2 part of the code. So the session 2 is this one, I believe, first example. Yeah, so we run this. So what we see, it tries to get an exclusive lock on the row, but this is updating it, so this has locked it. So we can't select this row with product ID 1. We're trying to update product ID 1, the price, but we're also trying to get it. This transaction is open, so it has to block the right session. It doesn't return because it's waiting for the exclusive lock to be released. To troubleshoot this, you can run some scripts. So I've gone on a tangent a bit, but I've got some scripts you could maybe run if you're interested. So this one shows us session IDs here and the type of resource that's been locked. Things like the object name, so the product table. So let's have a look further. We'll get back to that in a minute as well. We can also, the primary thing at the moment is the SID, the session ID. So down the bottom, right down here somewhere. Maybe it's actually hidden under there. If I hover over it, says 52. So this window is session 52, which corresponds to these rows here. And on the right, if I hover over that one, that says 57. So we can see that the one in the left is running with 52, the one in the right is 57. But what we see is 57, we can see it's waiting here, and that's this statement that's running. So its status is wait. It's a resource type is a key, so it's looking up this product ID by the key. So we can also run this if we want to know our session. That tells us we're 52. So if I run this again, we'll just have a look at what this says. So from the above query, we can see things like the resource type, e.g. key for the row in an index. We see the session. Ignore the numbers because these will be different. On my machine today it's 52, and as I say 57. So let's change that to 52. Is waiting as it has a status of wait, and it's not 52, it's actually 57 because it's the other session. So session 1 is in this left window, session 2, and they're given different session IDs. We can also see the name of the resource with the help of the object name function. This shows the blocking chain. So where we say object name, obj, we can actually see these are the objects further down. I presume this is like the object chain. 57, it's that one and that one maybe, so now we know the session IDs, we can run the following. We can even get the SQL that was run. So now we know we're in session 52 and 57. we can run that and actually query them. I've just realized I've put this in my master database. Never mind. I'm going to change it to playground again. I'm just going to do something quickly. Yep. Okay, bear with me. Playground. And I'll recreate it and I'll get to that point again. So I create my data, run the query, and running that as well. Update transaction select. I'm still on the wrong database. Hold on. What if I do? Sorry about this. You have to bear with me. Just trying to make sure I'm on the right database. Yep, playground. Okay, let's try that again. Execute. Okay, and this one, execute. Right, yeah, so it's blocking again. Sorry about that. So we just check our session is still the same. Yep, 52. So yeah, 52 and 57. Here you go. So this window on the left is 52, which is this row. This was doing this select here, which is reflected here. But 57, we can also interrogate and go, okay, well that's actually what it was executing. Select product ID, name, price, and that's equal there. So that's quite useful. We can also look in this DMV, so the dynamic management views, to see what user and where the request was coming from, giving you a good idea of what the sessions are doing. So this one, we want to know about the other window, which is 57. So we run this, wrong button, execute that. 57, there you go, and we know Andrew was doing something on this machine. So another one where we can query the blocking session ID, so we can see what is waiting. So this one is actually going to show us any blockers, things that are waiting, and this is actually saying this SQL over here on the right in session 52. The blocking session was 52 here, but the session ID over here that's waiting for that lock was executing this statement. But by now you'll maybe realize this just runs, doesn't it? By now you'll maybe realize that the lock timeout has no timeout. We can set a timeout with the set lock timeout command. So what we'll do is we'll actually, as soon as I roll back this will then be able to get the lock, and it does, it returns. Let's just do the set timeout. So this time I will run that statement again. Begin a transaction. We always have to roll back a transaction or commit it. You know, don't leave it open because you'll be in a funny state. So we open the transaction and update. We haven't closed it yet. But if I now set the lock for this session to 5 seconds and then execute, what we should see within 5 seconds, something will happen. Yep, lock request timeout period exceeded. So it's exceeded and it's given up. And it's rolled back the transaction if it was doing one. This transaction is still open. We'll do that. So we've shown that it blocks and waits until the transaction is rolled back or committed. You could have the word committed in here as well if you want to commit the change. In this case we didn't. So let's talk about isolation levels. So you can't control how writes behave for locks, but you can control the way reads behave. You can't set the isolation level at the session. Oh, you can set the isolation level at the session level or the query level. So isolation levels are the following. You've got read uncommitted, you've got read committed. This is the default for SQL boxed versions. You've got a repeatable read and you've got serializable. So as you go down this chain, it gets more strict and slower basically. The fastest type of queries are read uncommitted because they don't get locks, and as you go down you'll see that it's stricter and locks things more. So we also support read committed snapshot, and this is the default for Azure SQL, and there's also snapshot. The higher the consistency is, the lower the concurrency is, so that's sort of the rule behind these. You can set the isolation for the session by doing the following. So for this session, I want to set my isolation to read committed, which is the default out of the box, and I think that's what we're already in, but we just run that to make sure. Or you can do it on a query level. So here, I've never used this syntax. I always use this syntax. We've got select everything for a product and then read uncommitted. And you'll notice that there's no space in the name, whereas there is up here. So that's how we set the isolation level, set transaction isolation level, and whatever name it needs to be, one of these or these. So let's talk about read uncommitted. So we've already really shown you an example, but we'll just, oh no, we've shown you of committed, not uncommitted. So read uncommitted is the lowest isolation level. This level won't ask for a shared lock, so it is never in conflict with the writer. This means it can do dirty reads, which means it can read the data even in the middle of a transaction, which could roll back or fail. So let's expand this and get into the next one. Oh, to actually remove the timeout, we've set the timeout. You set it to -1. You could also kill the process if you wanted. You could use that command, vice versa, but we need to get to this point. So what we're going to do is we are going to update the product with a price, increasing the price by £1. So £12.95 is going to become £13.95. So if I run this, the transaction's open. We've made the change. We haven't committed the transaction, so the value is still in there. It's not committed, but it is in this session. So we set this isolation label now to read uncommitted, so not the default. The default is read committed. Read uncommitted we're going to try. So if you remember before, it blocked. If we run this now, what happens is it doesn't block, but what it's done, you will see that it could query the data as it did not request a shared lock. But this is also called a dirty read, because what's happened is it's read the value that's changed over here. This hasn't actually committed its transaction yet, but it thinks it's in there. So something on this session could come along and actually roll back the transaction like this. So actually when we select from it, the value is £12.95, but this one has just done a dirty read and it's got £13.95. So that's what's known as a dirty read. If it rolls back, then you've got the possibility of having inconsistent numbers. But maybe that's an acceptable approach for you. So the next bit, we're going to do read committed, which we've already really been through. This is the default for the box version and prevents reads from reading uncommitted changes like we just saw. So this will prevent the dirty reads. It will request a shared lock. So if a writer has an exclusive lock, then it will conflict and the shared lock will not be given. Hence, it will wait. As soon as the writer commits the transaction, the reader can get the shared lock and pull in the committed changes. So let's do this again. We're going to increment this value again. Still hasn't changed because we roll back. So transactions open. It's in £13.95 in the transaction. Read committed. We set the isolation level now to read committed instead of uncommitted. When we run this, we're back to what I originally showed you. This just sits and spins and waits because this has now got a lock on this product ID 2. We're trying to get product ID 2. Because it's a read committed, it will only get it when it's committed, so it's now blocked. So it waits. We can give it a shared lock by committing or rolling back. So in this case, let's roll back. Again, it could be commit, doesn't matter. Well, let's change it to a commit, because then you should see that will come back with £13.95. Or actually, no, let's keep it as rollback, because you can see it's £13.95 on the left. This is blocked, so you should see the rollback now gives you £12.95. So we didn't do a dirty read. So seeing as it only gets the locks on the data that it reads, this can produce non-repeatable reads. So seeing as it only gets the lock on the data that it reads, this can produce non-repeatable reads. Yeah, so this may make might make one select which selects the lock, and then something changes the data. Then if you call it again in the same transaction, it could have different data. This is known as a non-repeatable read. For many applications this is acceptable. So you may select something at the top of a stored procedure, then you'd have some more code, some more SQL, something may jump in within that period, and then you query it again for some reason at the bottom. That can be known as a non-repeatable read. You initially query it, get one value, something snuck in there, changed it, and now you've got a different value. So the next thing we can do is the next more lockdown isolation level is repeatable reads. So this can be used if you need the data to be read in a repeatable read in a transaction. This will need to hold a shared lock for the duration of the transaction. So the other one holds the lock just for the statement level. This is now locking for the transaction level. So this means that if something is trying to write the data using the exclusive lock, then it will be blocked until the transaction finishes. So we'll turn this on, repeatable read. We will begin the transaction. Oh, and in this case we're just trying to select. We're just selecting it in this transaction, so we're not modifying it, we're just selecting. So then we've got this in session 2 saying, okay, we'll update the price. So if I do that, what happens is we're blocked because this is in a transaction. Even though it's not an update, it's locked that row. You will see that it blocks as this transaction is open. When we commit the transaction or roll back, the other session will be able to write to the row. So if I now run this, commit, that then finishes, and now we've got a different value. I'd imagine, yeah, 13.95 when it was 12.95. Then there's serializable. So this stops phantom reads. This level not only locks the existing rows, but also future ones. It blocks attempts made by other transactions to add rows that qualify for the reader querying filter. So this is just even more isolation. But the more isolation you add, the slower it gets. Remember that. So we'll set that on. We're just doing a select, get me all timber, which we've got. The transaction open. We haven't finished yet. Let's try and insert a new one. But what happens is it just sits there because because we've done it on category. So if we could insert one that wasn't timber and it would work, but it's actually locked it for that specific category as well. So it's created a transaction, and anything with a type of timber you won't be able to modify until the transaction completes. So if I execute that, you'll see that that runs again. And if we run that now, we see we've got 2x2 car, whatever that is. Okay, so set isolation. So we're going to put the isolation level back to read committed, the default, which is here. And move on to the next bit. Okay, so isolation levels on row versioning. Okay, so SQL can store previous versions of committed rows to tempdb. The two isolation levels that support this are read committed and read committed snapshot. We will focus on read committed snapshot as this is the default SQL Azure isolation level. This is similar to read committed, but reads don't require shared locks, so they won't wait when the data is exclusively locked. Reads don't block writes and writes don't block reads. SQL Server provides readers with an older version of the row if the version is not the one they are supposed to see. So if you do a delete and an update statements, what it does is it copies a version, so you should be aware there might be a negative effect on performance when updating and deleting, but read performance normally increases as they do not acquire shared locks and hence no need to wait. So to turn on read committed snapshot, we need to first run this statement, When we do this, the isolation level will be set to read committed snapshot unless otherwise changed. You may also have to close the other session. So yeah, I've had to close this quite often. So I'm just going to run this. Yeah, that's run. Try and bring that other one back in again. SQL. Yep. Over, back over. Okay. So what we're going to do is find the next one. Read committed snapshot examples here. Okay, we've set that on. We're going to increase the price again. So the price is $13.95 in a transaction. Now notice all we've done is set the read committed snapshot. Previously it was all the other statements, or the default was read committed, like that one. Yeah. Now we've done read committed snapshot on. We've turned that on. You'll notice the syntax is a bit different. So here we've set the isolation to read committed, but then we changed the database and set this read committed snapshot on flag. So we have changed the value here. We haven't committed or rolled back. So if you remember previously with the default read committed, it would block. It would wait until this transaction's done. So let's start the transaction and select. And what happens is it returns immediately, but you notice the price is $13.95 and not $14.95. So the price is the older price, but it was not blocked to return the results. So if we commit the transaction and then run the session query to again, we can see that it now has the new value. So yeah, if I commit that and then run that again, $14.95, and it's pulled it in. So what this is doing when we put this on, when we're doing an update or a delete, it does a copy. It makes a copy of that value, maybe that row, but it makes a copy of it, so that anything that wants to query it can. Like you saw, this could still jump in and get the previous value whilst this is still changing it, and that's quite advantageous, really. I think I've done commit transaction. Yep, that's fine. So let's reset the isolation levels. I'm just going to shut this session again because I have had issues when running it, and then it seems to run much better if just in this one session. So we turn the snapshots off, and then we make sure our isolation level read committed, the default one, is back again. So I'll open that up again because we might need it in a minute. Drag it over there. We can also check this. So this is the statement, and just go all the way to the right. I've added this column here. We can check, is read committed snapshot on 0, which is fine. Yeah. So now we've talked about isolation levels and all the different types, and the faster ones and the slower ones, like serialization or serializable. We'll talk about deadlocks. So a deadlock is when two or more sessions block each other, e.g. session A blocks session B and B blocks session A. In any of these cases, SQL detects the deadlock and terminates one of the transactions. SQL will try and terminate the transaction that did the least work. So what we're going to do is we're going to create a sales order line. We're going to insert data, and we're going to look at what we've got. So we've got a sales order 1, 2, 3 with some product IDs, the quantity of them, and a total price. So now we can start the example. So of a deadlock, let's have a look. Scrolling, deadlock, yeah. Okay, so we're going to create a transaction. So what we're going to do, one transaction, session 1 over here, it updates the product, it sets increments the price, but the transaction is open. The next one, session 2 over here, he also creates a transaction, but he's updating a different table. He's updating sales order line. So the different tables we're touching. The next thing we do is, you imagine this is in a stored procedure or a transaction. We then do select everything from sales order. So this one is now saying, okay, go and get me this row over here, the sales order line. So let's run that. But what happens now is we are now waiting because this one's got the lock on it. And this is an expanded time period. You know, this would be a lot faster when you're running it, but this is how you can see how deadlocks work. So we're updating product here, we're updating sales order here. This one then wants to get the product that's being updated over here. And finally, this one, session 2, now wants the product that's being updated here. So when we execute that, you will notice that in a couple of seconds, yeah, it errors and says transaction process was deadlocked on lock resource with another process and has been chosen as the deadlock victim. Rerun the transaction. So this one has failed and this one has succeeded. So this one worked, this one didn't because of the deadlock. And a deadlock is basically a cross. If you visualize this one is being updated and this one's then trying to get a lock on that up there. If you draw a line from there to there, and then the deadlock is when you draw a line from there to there, you basically get a cross in the middle. If you have a look at deadlock diagrams, you can see them. I might have a quick look. Yeah, maybe not. No, I won't. It's not. But yeah, have a look for deadlock pictures, and you'll see where there's a cross. That's basically a deadlock. So what can we say about this then? So you should see after a short time that one of the transactions is terminated, and we get this message. The message below. So deadlocks are expensive because they involve undoing work. To mitigate deadlocks, you can do the following. Keep the transaction as short as possible and don't use the transactions that require user input. By swapping the order and making them use the same order, this can be mitigated. So if we had actually, the other statement had got the product and then the sales order instead of the sales order and the product, it could be mitigated, the deadlock. Having good index designs to support query filtering so that SQL doesn't do a table scan or lock the whole table. That's another option. So good indexes are key. You want to seek in and out, be fast, get the data you want, and get out of there. Don't lock it longer than it needs to. Also consider the isolation level. If it was reusing the read committed isolation lock, it would need a shared lock. If you were to use the read committed snapshot isolation level, the reader will not need a shared lock because it does the copy and temp DB. So this could be a good solution. If your reads are slow because you're locking, maybe it's worthwhile turning on read committed snapshot. Also consider read uncommitted if the weight of doing dirty reads is okay. So if you weigh up that I'm not going to get dirty reads, or you're not bothered about that, you can put the read uncommitted on. If you do that, it will speed up your procedure. Recently I had a procedure that was taking 2 minutes with the default read committed. I didn't the data was never changed after that because it came in as a batch of items, so I changed the stored proc to use read uncommitted, and it went from 2.5 minutes down to a minute, so you could see the performance difference. I've also provided at the end here a useful little script that I got from somewhere, and it's really useful to find locks at the current time. So what I will do is run this stored proc down here, execute it. I give you a little key at the bottom for the locks that are shown in this tool. So what we do is then we run this statement, but I've got that in this session window over here. So what this says is run this stored proc for this database every second and loop 10 times. So for example, if I go to the first statement at the top, and I'll run this first bit, so I'll open a transaction. Okay, so this is open. What I can do now is run this, just drag it across a bit, execute. Every second it will create a snapshot, or it should do, but I may have an open transaction, so bear with me. I'll commit that one. I'll just stick one in here as well. Make sure it's all clean. Okay, try it again. So that's run, transactions open. This one, transactions should return. Playground, yep. No, it's not too happy, is it? Query was cancelled. Let me just have a look that it's gone in the right place. Oh, it doesn't look too happy, does it? Locked request. We've got something locked. Execute. It was most probably that one, wasn't it? Stored procedures, refresh. Yeah, it was. Okay. I don't see the stored procedure in there. Check should be called check locks. Let's run this again. I don't know where it's went. Maybe because I rolled back. Okay. Yeah, okay. Let's stop that. Alright. Apologies. It's always something. So again, I'll create the transaction, update that row, keep the transaction open. So when I run this now, yeah, we can actually see snapshots every second. If I then do a rollback, we should see that the values start to clear. So the subsequent ones, it stopped locking. And I really like this sort of stored procedure. It's really useful for looking at what's having a little peek into the system at a point in time. Also good as a developer when you're running a stored proc and it's quite intensive. Maybe you don't want table locks. If your default isolation level is read committed, then you most probably be getting table locks and page locks. If you're actually not bothered about that, you can set the isolation level to read uncommitted, and you'll notice that when you run it again, your table locks have gone. So I've done that a couple of times. So in this case, we can see session 52, this database, this object, it's got a page lock and a table lock, IX. If we scroll to the bottom down here, we can see IX is intended exclusive lock. And it did a page lock because there's only like the page and table, there's only 3 rows in there. If we had more realistic data like thousands or 100,000 rows, it would have done a row lock or a page lock, but not a table lock. But it depends on what you're querying or what you're doing. So really useful to have a look. If you're running a stored proc for 30 seconds, run this and see what locks you're getting. But yeah, that's isolation levels. And deadlocks. So I'll just clean up my database, and that's it. Hopefully that was useful, and have a good one. See you later. Bye.